I'd like to say hello to everyone. I'm going to tell you about the experimental study about fear, anxiety, panic, the common points, and what are the points that we start off from, and how will we evaluate all the three together. That's what I'd like to touch on. And the general outlines I would like to mention about what has been done up till now, and the concepts, and if there is a network, we could call it the fear network, where these concepts can be explained in the brain, how it works. And the second experiment is another part, and I'll try to share the result with you, and I'd like to draw some conclusions. In the clinical sense, the descriptive approach in defining our patients, it is observed as an indirect method, because we don't have a marker. So there are certain indications and symptoms that are brought together, and we use the disease concepts. Clinically, that's possible, but while looking into the etiology, this can create confusion, because a symptom can exist in more than one disease. When we talk about panic, fear, and anxiety, when we say fear, for example, or what does it mean, anxiety in general? Is it the concept of anxiety disturbances, or is it just plain anxiety we use in daily life? And when we panic, is it a panic disturbance or a panic feeling? I don't want to complicate things, and if we're going to talk about neurobiology and concern the brain structures, we have to get a common point for all these three. And in what system in the brain is this related to? Fear, panic, anxiety are all clinical situations. But one thing that is common, that there is a threat that exists. What sort of a threat exists in panic? Fear of drowning or dying, or the threat, for example, something that bad is going to happen, the expectation and the probability. The anxiety, this is a probability. In a panic, it's sort of losing your mind, like drowning and so forth, losing your balance. In fear, and previously something that we had feared is the threat, the common thing that there is a danger, the probability of a threat that exists. And we start off from the concept of a threat, and if a threat, in what structures in the brain does it concern, what sort of behavior does it lead to? If it's a potential, probable threat, then the behavior of the individual is a risk assessment. They are preparing themselves for a probable threat. In animals, for example, the previous activities is suspended to go around the social environment, and joining the others are suspended for a time. In human beings, in case of anxiety or loss, we postpone our anxieties. For example, social activities like going to the movies or going out, we postpone it, so we hesitate and we are anxious. It's a risk analysis. In the brain, the septum, the hypothalamus, the amygdala is involved in the risk assessment. What we feel is anxiety. And in the disease dimension, and compare it to clinical, it's an expression of anxiety disturbance. There is a threat, a probable threat. You feel anxious about it. Both the body and the psychological being is preparing itself, is more alert in preparedness. And if there is a conditioned stimulus, something that we encountered before, and a situation that accompanies that, for example, you feel certain perhaps claustrophobic in the market, or something that had not bothered you before, could be a sound, a light, a noise, and so that becomes a stimulus that is disturbing you. And this time, freezing behavior is the first choice. In the freezing behavior, as it was explained before, the ventral periaqueductal gray and the amygdala is involved. What we feel is anxiety. This anxiety is an expected anxiety. And also, if our behavior is like avoidance and fleeing, and the amygdala is more involved, it opens the way for learned fear, and this exhibits itself in a way to explain phobias. If there is a danger that exists but is not very threatening for us, and we call this a distal danger, then we try to escape. Flight is what we choose. And the medial hypothalamus is involved. This is an innate fear, what we observe, in anxiety, apprehension, that is innate, and accompanying physical indications, bodily indications. And if there is a really severe threat, then it's flight or freeze, or in another way you either flee or fight in an auxiliary manner. That's the dorsal periaqueductal gray, and the panic disorder would be the definition of the pathology. We're starting off from the threat of a probable danger. It might be realistic or not, but it is conceived as a threat by the individual. It activates the different brain structures and leads to different clinical outlooks. We talked about these concepts. What parts of the brain can be involved in this network of pain? Amygdala is our center to start with. The amygdala, as you can observe here, is within the structures of the midbrain on the part of where the temporal structures are present. The amygdala is in one of its important functions, that it is where fears and anxieties are housed there, stored there. And also our memory of safety are in the prefrontal cortex part of the brain. Amygdala is observed in the brain as a small structure. We might think of it as a center where our emotions are stored, but we see the attachments to the root of the brain, and there in the vagus and other parts, the serotonergic pathways, and actually it gets connections there. The amygdala we observe there, but the connections on the brain root and the hypothalamus, the thalamus, and even up on that, and these are the existing connections. The frontal cortex, prefrontal cortex as well, and also in other brain structures, as we have seen, it's a structure that has important connections. Clinically, anxiety, fear, when all these are brought together, things become more clear and evident. Hippocampus is another part, and that is where the memory is coded. It's not the emotional memory, but knowledge information is stored here. The prefrontal cortex, fear, anxiety, for example, prefrontal cortex is important. The thalamus, as you know, is for emotions. Also, it's the area which decides about directing various information. Thalamus. Anterior cingulate cortex, and especially This is where memory is stimulated. Locus cerebrus, which I showed before, is at a lower place, a center where the neurological pathways are concentrated, the hypothalamus. Another important structure is the nucleus accumbens. In schizophrenia, there are certain theories based on this, but especially lately in the laboratory, this impulsivity has relations to nucleus accumbens, and in fear and anxiety, the sudden aggressive behavior could be related to nucleus accumbens because it does have contact with that. The periaqueductal gray material, the region, I listed these one by one, but as I stated before, is there a fear network, or are all of these centers or regions show certain clinic indications or reactions, or is there a fear network that's working out of a center? And normally, when we have a stimulus from the outside, and this could be the nucleus, and this could include the tractus.
Glossopharyngeus has a role in pH neutralization, and for the respiratory there are lots of important nerves. In the tractus or from the outside, if there are some responses, if there are some stimulations, the first station is sensory thalamus, and sensory thalamus decides the way. In a normal process, the hippocampus has a role, and thalamus has the information, and lateral nucleus of amygdala and basal nucleus of the amygdala. All of the stimuli has evaluated, and at the end, central nucleus of the amygdala has been evoked. And at the end, prefrontal cortex and cingulate region has evoked, and after the stimulation, which reaction will be decided.
And again, we see that the sensory thalamus, the stimulus is sent, and vis-a-vis the stimulus, if there is a reaction like fear or in the form of anxiety, locus cerebrus is effective there. Our palpitation, the heart rate increases, periaqueductal gray region is stimulated, freezing or flight, and if the parabrachial nucleus is stimulated and the respiratory rate increases, hypothalamus, in the hypothalamus, the paraventricular nucleus and the pituitary secretions result, and cortisol from the adrenal glands, cortisol is secreted. The lateral nucleus is the autonomic pathways. When there is a warning, a stimulus, and it's conceived as a threat, based on the type of the threat, certain centers are stimulated. And if the threat is not too great for us, and it's not life-threatening, this process works through the thalamus, screens that the amygdala then sends a warning to the organs, but the prefrontal cortex is coordinated. After deciding which behavior is the appropriate one, the stimulus is sent over the amygdala, and the fear center can be defined in this manner. The amygdala is the most important region for the fear center. And it's a bit speculative what I have said, but I'm working on this subject and I'm trying to base things on a sound base in my mind. If we try to consider these separately, it's difficult and chaotic. In fear, what systems are related? In panic, what systems are related? If we provide such an explanation from what we have learned, in panic disorders, we see that the individual is afraid of losing their mind or drowning or dying. But the symptom is more frequent intake of oxygen or respiration or feeling of suffocating, the heart rate increases. So based on the system, more rather subcenters, the vagus angulocephacus is a part of it which would give a pre-warning, or is it like an alarm system? Well, for example, the blood pressure increase, but it's not threatening. The oxygen is reduced, but it's not life-threatening. And if we have from going through this, the tracheosolitarius, and it stimulates, and there are warnings and stimulus like a bombardment, and the amygdala is stimulated. Normally, prefrontal cortex should suppress the amygdala. In panic disorders, this excessive sensitivity, the early warning alarm system, is it because that the amygdala is excessively stimulated, so that panic disorder is resulting from this, from shortness of breath and high blood pressure? Perhaps the amygdala is not inhibited satisfactorily. Decision was made that there is no threat, but the lower centers are in panic. That gives the sense, the messages that something bad is happening. Perhaps in panic disorders there is an excessive stimulus on the amygdala, and since there is no sufficient inhibition, the individual feels these emotions highly, excessively, and so when they are in the same situation, they fear that the same things will happen. And actually, when we talk with the patients of panic attack, you have seen that it's very difficult to persuade them. I'm suffocated, my heart is beating hard, for example, and I know logically, but at that moment I can't control myself. Perhaps the prefrontal cortex at that time, vis-a-vis the stimulus coming from the lower centers, and it is unable to fulfill the inhibition satisfactorily. Could that be a possible preadductal gray material stimulus in the similar manner? Warning comes, stimulus comes, and a threat is conceived. Perhaps some of it is speculation. We have the prefrontal cortex, but because the inhibition is not satisfactory, the individual feels as if they're really going to die and is in panic. And starting off from that, in treatment, our interpretation would be, perhaps you heard in the previous presentation, plus medication. For example, in panic disorders, psychotherapy is very beneficial, especially with psychotherapy. Sometimes it can be satisfactory, but there are oversensitive individuals which give out signals all the time. For prefrontal cortex to be active, that are certain regions that need to be inhibited, and that, for example, we could provide that the prefrontal cortex should be influential with psychotherapy. especially in the prefrontal cortex, understanding, interpreting, conceiving, all these relations are things that we want our patients to undertake. And with psychotherapy, we are strengthening the prefrontal cortex so that they will be able to employ inhibition in a satisfactory manner. And in fear, how can we explain this system? For example, it warns the centers in thalamus, but in fear, especially at the simple level and in high severe stimulus, the prefrontal cortex does not come into play because it's a serious conception of threat. Decision must be made very quickly. With thalamus and amygdala, and it's not expected to have those actions as very logical, because conceiving and understanding comes later. First we undertake the behavior and then try to find out, account for ourselves whether it was correct or not. When you confront something that is a warning, a stimulus, the behavior is not different, except behavior, yelling and running away or freezing. But the shortcut comes into force. The problem here is that the conception of danger, that it's conditioned here, and this in the amygdala is coded as very dangerous, because amygdala gives a reaction. The hypothalamus is stimulated, other subcenters go into the process, then the cortex come in at a later phase. In fear, we know that medical treatment does not have a very good outcome. The inhibition must be undertaken quickly, and the psychotherapy, so that when individual encounters that again, we want to break through from the same reaction, because that's something that's been coded as a threat in the amygdala. And the stimulus to the amygdala shows us the short pathway. But with the inhibitor effect of the prefrontal cortex comes into force, that it will not be, the thalamus, the hypothalamus will not be stimulated, that things are not so bad. In anxiety, what happens? It's more difficult to explain anxiety. Most likely all of these systems are active in anxiety, but in an unorganized, irregular manner. The stimulus from the up, above and below are coming but disorganized. In our experimental work, as Lee mentioned, there is something else that I'd like to share with you. The work has not been concluded. There are other analyses that we have to undertake. As Lee has pointed out a little while ago, we had an experimental panic model. In rats, panic behavior became apparent. After the stimulus, the rat was placed in an open area, and the rat under the same environment was conditioned and showed the same fear, panic behavior. And in our groups, we had escitalopram, especially in the early gene transcription marker. C4 was activated, but buspirone was not activated. And that's our hypothesis. Actually, here the rat, when placed in an open area, we also tried the agoraphobia model as well. In agoraphobia, if an individual feels negative feelings like in the open field, usually do not want to go to the same threatening environment to avoid it. The rat, in the same manner, tried to avoid the environment of the previous experience. but the agoraphobia model could be analyzed with this method. This is how I can roughly show or indicate the system, and also the regions that we tried to analyze. The amygdala is connected to many regions, as you can observe here, and we analyze all of them, especially during panic attack. The activation, which region is activated or not, was considered, but as you can see, there are many regions, and the ones that I have underlined are the ones we've gone through. When it's completed, I hope that I will have the opportunity to share this with you. What sort of a method we have used? We're undertaking that in Turkey. And in this method, cells were counted, but this was not an acceptable method because it's the only cell number, but actually in 3 dimensions consecutive sections are taken. The organ cells can be counted, and with a computer program and formula, the repeated sections are counted and the cell count can be received. We had consecutive sections of amygdala, and the neural count can be achieved through this method. This was the computer program. If you want to have the detail, I could offer it to you later on. There's the cell counting. The CFOS activations are the small black dots, and for each region this was computed in every region. And what will be how many regions and the results shall we be sharing? And the CFOS activation, for example, it's in the form of small black dots. And this is the group which had the electrical stimulation. The other had an electrode placed, but no stimulus was undertaken. And the prefrontal area is quite concentrated, but there is no electric stimulation, and there is no CFOS activation. Behaviorally, the panic model and the panic-like behavior of the patient, but biologically, histochemically as well, what is taking place in the brain can be indirectly felt in this manner. Graphically, if we show the same thing, buspron that is administered to stimulated animals, and also buspron given to non-stimulated animals are compared. If you want to discuss it, it's a bit complex, but buspron appears to have increased. We discussed this amongst ourselves, so there is no stimulus. Normal is that it should remain. But the explanation was that buspron, when it is administered, can have or result in an anxiety effect. Buspron I thought was a partial agonist, but it has a dopaminergic effect as well, and there's a lot of recurrent accumbens as well. And so with the dopaminergic effect, even if there is less stimulus or source of anxiety, individuals that have buspron, or animals I should say, anxiety indications can be seen. And CFOS activation is expected. It was not reduced as we had expected it to reduce it. This is another version of what I have shown, the neuronal count. And when we compare CFOS with buspron, and as you can see, CFOS activation can be overcome, but buspron is not observed to show the same effect. And the CFOS activation, if we compare that with escitalopram, very little CFOS activation, but buspirone has a higher CFOS activation, and the amygdala HIPOS activation is observed in the buspirone group. The black dots is not very effective on CFOS activation. That is a clinical response or a proof. So how can we conclude? Certain materials can lead to panic attack. Some people are sensitive, genetically sensitive makeup, and they're more sensitive, and especially they have an alarm system in response to stimulus. Some situations of materials can easily have an effect on their sensory activities, and the most important center for that is amygdala, but amygdala doesn't undertake that by itself. The thalamus, hippocampus, hypothalamus, and peridoxal gray region, locus ceruleus, and other brain stem sites are active as well. And as the question was asked, does it have any effect of other systems, that is SSRIs? When we think about it, SSRIs regulate serotonergic production and increase the amount. But here we see that indirectly, as serotonin is increased, the overactivity sensitivity is inhibited, so that the panic symptoms are reduced, amygdala is less stimulated, so with psychotherapy it becomes easier to influence the prefrontal cortex. So this can explain in an excellent manner the results of medication and psychotherapy. And we also see in panic disturbances, first if the physiological symptoms are depressed, then with psychotherapy it is easier for the patient to get together. And also we see that if we provide satisfactory inhibition, then the oversensitive alarm system coming from below can be pressured, and we only give medication to our patients and do not interfere in that mechanism. And if the patient faces the same situation, the symptoms will give rise to fear and anxiety. But medication and psychotherapy needs to be administered together. In Erzurum, especially our team that carries out the histological analysis, and from the Psychopharmacology Society, a scholarship was granted me. I worked in the Neuroscience Center in the Netherlands last year. Thank you for your attention.